Chapter 2, motion or describing motion. When I want to describe motion, first I need to understand that there are scalar quantities and there are vector quantities. Distance and speed are scalar, displacement and velocity are vector. So if I come and ask you, compare between speed and velocity, mentioning the word scalar and vector in your answer, what would you say? Speed, yeah, speed is a scalar quantity because it has a magnitude only. Velocity is a vector quantity because it has both magnitude and direction. That's right. If you want to find the speed, you divide distance by time. But if you want to find the average speed, you divide the total distance by the total time. Exactly. This if the object was moving at a constant speed. If not, then we have acceleration. And acceleration is the rate of change of velocity, not speed. Because acceleration is vector, so when you come to discuss acceleration, you say it's the the rate of change of velocity. Measured in meter per second squared, rate of change of velocity means change in velocity, which is v minus u, divided by t. So our equation is v minus u, v standing for final velocity, u standing for initial velocity, and we divide this by time. That's the first column on the left, as you can see. What is free fall? A free-falling object is an object falling without the presence of air. So if we neglect air resistance, all objects, regardless of their shapes or masses, would fall at the same time if dropped from the same height. So whatever the mass is, whatever the shape is, since we are neglecting the presence of air, so they all behave similarly, they all fall at the same time with the same constant acceleration. They all fall with the same constant acceleration. We call it free fall acceleration, which is, yes, g, 9.8 or 10 meters per second squared. So any question involving free fall, I know from the beginning that the initial velocity is equal to 0, but the object was not moving at the beginning, and the acceleration is 10 or 9.8 meters per second squared. So we can solve using the equation of the acceleration, knowing that initial velocity is 0 and acceleration is 10 meters per second squared. And you can find whatever you are asking for. Now, this very important part over here, the graphs of motion. The graphs of motion, and we will be solving a couple of questions after we finish this. The graphs of motion are really important. And we have mainly two types of graphs. Displacement time graph, and the gradient for displacement time graph is velocity, because you remember gradient is y over x, so displacement divided time is v. Any straight line, not horizontal, represents constant velocity. If it has a positive gradient, it's moving forward. If it has a negative gradient, it's moving backward. And any horizontal line in a displacement time graph represents object at rest, yes, stationary. Why? Why? Yeah, because any horizontal line has a gradient of 0. And since the gradient represents velocity, so a 0 gradient means no velocity, so object is not moving, it is at rest. So again, any straight line, not horizontal, represents constant velocity. If it has a positive gradient, it's moving in one direction. If it has a negative gradient, it's moving in an opposite direction. And if the line is horizontal, then it has no gradient, and therefore it's at rest or stationary. Okay, what if it is curved? Yeah, look at these curves over here. To understand any curve, if you remember what we said before, you need to look at two things. The gradient, is it increasing or decreasing? An increasing gradient represents acceleration, velocity is increasing. A decreasing gradient represents deceleration because velocity is decreasing. A positive gradient is in one direction, a negative gradient is in an opposite direction. So these two factors, if you understand them, you understand everything related to the curves of the graphs. Gradient increasing or decreasing, acceleration or deceleration, gradient positive or negative, forward, backward, up, down, right, left, opposite directions. That's it for the displacement time graph. If I move for the velocity time graph, now the gradient changes because the gradient again is y over x. In a velocity time graph, the gradient is what? Velocity divided by time, representing acceleration. So any straight line, not horizontal, represents constant acceleration. If the line is starting from zero, whether going up or down, this is constant acceleration. If the line is going towards zero, whether it's up or down, that's constant deceleration. The up part, the above the x-axis or the time axis, the velocity is positive, so it is in one direction. The one below the x-axis, the velocity is negative, so it's in an opposite direction. So understand this. The VT graph, velocity above the axis, above the x-axis is positive, velocity below the x-axis is negative. So any line you draw below the x-axis represents negative velocity, which means object is moving in an opposite direction. And any line above the x-axis would be moving in a forward direction. Can be forward, backward, up, down, right, left. You need to understand that they are in opposite directions. And any horizontal line is representing object moving at a constant velocity, because the horizontal line has a zero gradient. So when the gradient is acceleration is zero, it means object moving at a constant velocity, except if the line is on the time axis itself, where velocity is zero, then we say this object is at rest or stationary. Okay. Any doubts? Okay, next part in this graph is the velocity, the area under the VT graph. The area under the VT graph represents distance covered. And to calculate the distance, it depends on the shape. To calculate the distance, it depends on the shape. Triangle, rectangle, square, trapezium, any shape, we are calculating the area of the shape under the graph, and this is representing the distance covered. And the area of a trapezium, don't forget it, it's half a plus b into h. See the curves on the right? The VT graph, if it has a curve, then this means acceleration is changing. If the gradient is increasing, this represents acceleration increasing. If the gradient is decreasing, then this represents acceleration decreasing. These two graphs, these two curves, the ones you see over here, both are going upwards. So both have a change in velocity and increase in velocity. So both are representing acceleration. The difference is the one that has an increasing gradient represents increasing acceleration, and the one that has a decreasing gradient represents a decreasing acceleration. If you want to find the velocity at any time, and it's a curve, then you need to draw a tangent at that point and find the gradient. If you want to find the acceleration, at any point, then you need to draw a tangent and find the acceleration of the tangent at that point.